All right, this is 3.1, inequalities and their graphs. In this lesson, we're going to learn how to write, graph, and identify solutions of inequalities. For the review, cross out any points that are not solutions of the equation. Negative 5 times g equals negative 15. If I solve that, divide both sides by negative 5, if g is equal to 3. So that means these numbers, negative 15, negative 5, negative 3, 5, and 15 are not solutions. Write two equations using 3, 13, and k. There's a lot of equations you could write, but 3 plus k equals 13 would do. 13 minus 3 equals k. You good? Check out this definition. An inequality is a mathematical sentence that uses an inequality symbol to compare the values of two expressions. Remember, you can pause the video whenever you want. Skip the parts that you don't need to hear. Go straight to the answers if you want. So here we have some equations and inequalities. We should be able to identify which are equations and which are inequalities. All right, the inequalities will have an inequality symbol. The equations will have an equal sign. So this is an equation. This is an equation. This one's an inequality. This one's an inequality. And that one's an inequality. If we complete each inequality with less than, greater than, less than, or equal to, or greater than or equal to, we get z is less than 4, so that really means all numbers are less than 4, so that means 4 is greater than all numbers. G is greater than or equal to negative 2 means all numbers that are greater than or equal to negative 2, so that means negative 2 is less than or equal to all numbers. M is less than 7, so that means 7 is greater than M. All right, for problem 1, we are going to represent this phrase with an inequality. It says all real numbers x that are less than or equal to 5. All real numbers x that are less than or equal to 5 would mean that that 5 is, so that means x is less than or equal to 5. All numbers that are less than or equal to 5. Or we could also write that 5 is greater than or equal to all the numbers. Notice that 5 is included in this since it says it can be equal to 5. The way we show that is by putting a line underneath the inequality. 4 less than a number y is greater than 10. The way we write 4 less than a number y would be y minus 4. And to show that it's greater than 10, we would write greater than 10 like that. What is an inequality that represents a verbal expression, all real numbers p greater than or equal to 1.5? Right, true or false? A real number p could be less than 1.9, 1.5, that would be false. A real number p could be equal to 1.5, that's true. A real number p could be greater than 1.5, that would be true. So the inequality that represents greater than or equal to is this one, and so that would look like that. The solution of inequality is any number that makes an inequality true. The solutions of the inequality x is less than 5 are all numbers x that are less than 5. You can evaluate an expression to determine whether a value is a solution of an inequality. So to see if 4 is the solution to this inequality, we want to check the truth value. So we're going to substitute 4 for x, subtract 2, and see if that is less than negative 1. So I'm going to put a little question mark right here. We don't know yet. 3 times 4 is 12 minus 2. Is that less than negative 1? 12 minus 2 is 10. Is that less than negative 1? The answer is, that is false. So negative 4 is not a solution. And to check if negative 3 is a solution, we're going to do 3 times negative 3 minus 2 and see if that's less than negative 1. 3 times negative 3 is negative 9 minus 2 is negative 11. And negative 11, is that less than negative 1? That is true. So negative 3 is a solution. All right, so they got it here. Consider the numbers negative 1, 0, 1, and 3, which are solutions. So we need to check each of those in the inequality and see if they're true. Here's an example of checking negative 1. So we're going to substitute negative 1 in there for y. And then do the math. 7 times negative 1 is negative 7. 13 minus negative 7 is 20. Is 20 less than or equal to 6? The answer is, that is false. So negative 1 is not a solution. So that's what you're going to do here. I'm just going to pause here and then show you the work for the other solution. So if we look at the work for the first one, we see that 13 is less than or equal to 6. That is false. So that's not a solution. 6, in the second one, 6 is less than or equal to 6. That is true. That is a solution. And the last one, negative 8 is less than or equal to 6. That is true. So we can see from the work here that 1 and 3 are solutions. When you're graphing inequalities, a closed dot on a graph means that the number is part of the solution. An open dot on a graph means the number is not part of the solution. So if the endpoint of the graph is negative 3, is negative 3 a solution of the inequality represented by the graph? In this first one, negative 3 is not a solution because of the open dot. In the second one, negative 3 is a solution because the dot is closed. And number 15, so the endpoint of this graph is negative 5, and negative 5 is a solution because the dot is closed. In the second graph, the endpoint is 7. 7 is not a solution because the endpoint is open. So what is the graph of 4 is greater than or equal to b? We can see from this that 4 is the endpoint. And since it says greater than or equal to, that means 4 is included. So we are going to put a closed dot on 4. And we want to make sure that 4 is greater than or equal to all the numbers that we graph. So that means that the numbers have to be smaller than 4. So if I graph that, that's going to look like all of these numbers going this way. Here are the answers. Problem 4, what inequality represents the graph? All right. One thing you'll notice on this graph A is that the dot is closed, so that means -2 is included, so that means we either have less than or equal to or greater than or equal to. And since all the numbers that are shaded are less than, smaller than -2, we're going to say x is less than or equal to 2. On graph B, since the circle is open, that means 1 is not included in the set, but everything, all the numbers that are greater than 1 are included. So we're going to write x is greater than 1. If you want to pause and do these problems, go ahead and do that, and I'll put the answers up shortly. All right, one inequality describes each situation. Be sure to define a variable. In the first picture, we see that you must be at least 4 feet tall to ride this roller coaster. So we're talking about height, so I think we're going to use variable h. And so if we look at that, we know that somebody that's 5 feet tall or 6 feet tall can ride this roller coaster. Any numbers lower than that, they could not ride this roller coaster. So we need all numbers that are greater than or equal to 4. So h is greater than or equal to 4. Now that would mean that somebody that's 100 feet tall can ride this roller coaster. We may want to qualify that and say, that there is some top limit to how tall you can be, but really, according to the sign, anybody that is any height greater than 4 can ride the roller coaster up to infinity feet tall. So in the second one, we have the speed limit is 35 miles per hour. And anybody who's driven on a road knows that your speed can be any number up to 35 miles per hour. So that means that, and we'll use S for speed, and we could write the inequality, your speed is less than or equal to 35. But that inequality would include numbers like -50, which are impossible speeds. And the other thing is, I don't think a speed of 0 would work either, because it's not legal to just be sitting in the middle of the road stopped. So, we also have another inequality here, that your speed should be greater than 0. Go ahead and try the got it. You can check the answers shortly. All right, here's your answers for this. And the lesson check. Go ahead and do the problems. I'll reveal the answer shortly. X is greater than or equal to 0. Counting numbers are like 1, 2, 3 natural numbers. In that case, it could not equal 0, so that would go here. Length of a poster, that would have to be some number more than 0, so equal to 0 would not be possible, so that would go here. One baseball team score, baseball team could score 0 runs, so that could equal 0. We'll put that up here. Whole numbers, 0 is a whole number, that goes there. Distance from home to a park, I suppose if you lived in the park, then the distance would be 0, so I think that's possible. Inches of rain, that could be, it could rain not at all, so that could be up here with greater than or equal to. So when x is greater than or equal to 0, that includes 0. And when x is less than, or when x is greater than 0, that doesn't include 0.